Yeah, so essentially what I'm going to mainly go through today is setting up, the environment and how to use Git. But essentially, in nearly all software development projects, you have a thing called SDLC, so Software Development Lifecycle. And with the waterfall methodology, you usually start from requirements, and then feasibility, and then design, coding, testing, installation, deployment, and maintenance. And if you're doing it in an agile method, it's essentially the reason why you would use agile is because you might not have all the requirements set out for you. And just think of agile as mini waterfalls for every single sprint. So it's iterative, and every single sprint that happens, you gain more requirements, and you do more design, you do more coding, and you do more testing, and then you deploy features of the code, or features of the software product that you're making. And you can create, you might end up creating releases for every sprint or every milestone that you reach. But I'm not going to go through that into depth. What I'm mainly going to focus on is mainly the version control, the Git side of things. So firstly, I'll just read through over the dot points that I've made. So first, we would set up the environment, and I've created links just to make it easy for getting references. And I'll just talk about the high level theory of why Git is used and how it's usually used in the industry. So the main reason why Git is used was because there used to be a time where the internet was fairly terrible and fairly slow, and it was difficult for developers to share code and work on code simultaneously. So what they used to do would be that one person would write the code, and then they would put like a version stamp or a timestamp or whatever whatever naming standard they put on their piece of code. They would put that on the code, save it, and then if they wanted to get someone else to work on the code, they would copy that file, put it on a USB drive, and then give it to someone else. Or they would have a centralized storage space where people can access that storage, and they would copy that code, and then other developers would work on that code, and then they would put their own timestamps on it, or they would put their own convention of saying that they worked on this piece of code. And then when it got to a certain point where two different developers had two different versions of the code, they would just sit down together, and this is what you'd find in extreme programming, where you have pair programming, and they would sit down together, and then they would go through line by line to figure out, how do you combine line by line of code, and how do we make sure that there's no conflicts, or we fully test and make sure that there's no bugs in the code, right? So they do that, and then after that they have a final code, and then they deploy it on the servers, or they test it first and then they deploy it. And that process would be fairly lengthy because there would be a lot of clashes in timelines and code, and it was just really messy. So it was out of necessity that people had to create version control, because they needed a way to sort of they needed a way for two developers to work on the code simultaneously while not interfering with each other's code or development. So
like management.
Yeah. So it's sort of like what I was showing you before with Jira. You've got individual issues for individual team members, and then they're assigned a different task, and they work on different tasks, and they don't have to go sit down in a physical room to figure out who's working on what, because it's all online. But that's what they used to do when they didn't used to have those tools. They used to have, like, say, meetings physically, and then they used to discuss, this person's working on this, and this person's working on that, and they would have like a board with sticky notes of putting names down and putting names on those sticky notes to say, oh, this person's working on this and the other person's working on that part, right? So I'll just go back to that Git branching. So Git itself, if you know the fundamentals of why it's used, becomes it becomes simple when you know how to use it. And that's obviously with everything else. When you know how to use it, it becomes simple, right? But when you're just looking at it, it's like, oh, wow, there's like a lot of commits. There's a lot of branches. It's all confusing, right?
Yeah.
So essentially, at first, people would just when they made versioning, people would just work on one branch, and it would just be like the master branch, and then still it was disorganized, because what if you had an extra feature that you wanted to implement on the side, right? And you wanted a release version to release to your customers. You wanted to have a release version for your customers, but then at the same time you're developing at the same time. So you had to have different versions of the code, and how do you keep track of that, right? So what they've developed is that you've got the master, which is what the customer sees, or the final version of the code. So see how there's different tags, and they're pretty much releases, right? So tag 0.1, 0.2, 1.0.
Like different versions, yeah.
Yeah, so when you have like patches and all that of software, and you've got different versions of Microsoft and all that. In the back end, they basically have something like this where that version is on their master branch, but you've got other versions where they're working on that code in the back end, right? So now you've got the master, but then you've also got like a version of that in develop, and these nodes are basically what you call commits. So just think of this whole these lines as a whole timeline, right? And say each of the nodes are every time you push a code on the remote repository. So you're going to have two versions of the repository. The one version is on the remote, where it's stored in the cloud somewhere, and that's where there's a central version where people can access, right? But you also have a local version on your device where you can work on it, work on it just locally on your device without affecting the remote repository. Because if you work on the remote repository and you change that, right, then you could affect someone else's version of the code. So what happens is that you pull the code from the remote repository and you start working on it on your local device. And then when you finish working on it and you finish testing and all that, then you push the code from your device to the remote, right? And that's when the remote gets your version of the code, and then other people might have older versions of the remote repository. So whenever they want to sort of add their code to the centralized repository, then they will have to pull the code from the from the remote repository, right? So I'll explain more about that later, but in this case, so you've got the development branch, and then that's where you do that's where what the high level of the development of the company, right? That's where all the development sort of goes to, and then if say you're working on a specific feature, then you create a separate branch for that, and you pull the code from the development. So essentially what this is doing, so you're at this point, right, you're creating a copy of the code at that node, and then you're pulling it to this feature branch, and then now you're making changes on that feature branch, and now on that feature branch, the version of the code is much different than what you see on the development branch. But once you finish working on the feature branch, then you merge it back into development, and other people at the same time may have created different versions of the code while you were working on the code, right? So there's going to be what you call there's best practices to, working on code, and essentially it's good to separate concerns and separate what you're working on. So if someone's working on, say, one class or one object or one section of the code, you need to be working on another section of the code so that your code doesn't conflict, right? But if there's a case where you have to work on the same section of the code, and then your version of the code is different than their version of the code, then once you sort of merge the two branches together, there's going to be called what you call a merge conflict. And when there's a merge conflict, Git creates another file that has both versions, and it annotates which version is which, right? And it asks you to choose which part of the code you want to replace in those lines. So if you actually wanted, say, if you've got two team members that are working on the code and they have two different versions of that section of the code, that those couple of lines, and then say team member 1, you didn't want to use his code, but you wanted to use team member 2's version of the code, then you just select the team member 2's version of that code when you're resolving that merge conflict, right? And then once you resolve that merge conflict, it creates another commit. So there's different ways, there's different methods of actually setting this up. So sometimes what you can have in a company is that instead of having this setup where you have feature branches development and release branches and hotfixes, right? Sometimes you just have one trunk and then everyone works in that trunk. And having a trunk is usually good for CI/CD, where everyone just works on one branch and everyone just commits to one branch, and they use feature toggles. They use feature toggles to enable features and disable features so that it doesn't interfere with the whole program, right? So you could do it that way as well, because that actually simplifies everything, and it forces people to sort of continuously integrate code with the code base. So that's one methodology. This is another methodology if you sort of want to modularize, or if you want to have separate feature branches for separate things. So that's sort of the basic theory on top of Git, right? Now, let me just go to the cheat sheet, and essentially you're going to forget, the commands, right? Because there's so many commands, so many unique ways of using Git. You could use, the IDE. You can download an app that actually, I forgot the name of the app, but you can use that to visually see, the branches and how everything fits together. But a lot of programmers just end up using console once they get used to it, because it's easy just to type in, commands to, update the repository. So here you've got, you've got the basics. We've got git stash, git add, git reset, git diff, git commit, and you'll see me using this as I go through, the tutorial.
Mm-hmm.
Yeah. So that's just for reference. Okay. So I think a good practice, like I was looking around before to see what projects to use for this tutorial, for us to practice using version control. So I chose this one. So essentially it's just a counter. So it's a React.js app, and then if you actually go to the actual app, then so it's just the front end app that you can just start counting numbers on it, and then you can remove, subtract, refresh, or and then see how this cart object or cart image updates. So we're probably I just wanted to sort of make a simple example where, say for example, we have the app and our requirements says add extra counters, change colors of counters, change fonts of counters. So before we start anything, I was thinking maybe I might show you sort of like Jira, right? So if say you got a requirement from, and this is like the Jira board. Let me just dual screen that, so, or yeah, split the screen, so it's easy to see. So yeah, usually you would have like requirements from the clients, and I'm skipping a lot of steps, but usually at this point you would have broken down the requirements, and you would have, you know, an SRS software requirement specification document, and then you'd have user stories, and then you would split those user stories into like, you know, features and what you need to implement, right? Now, the way you track that when you're coding is that depending on how it's set up, if you're doing Scrum, or if you're doing, in this case, the Jira board is set up as Scrum, so that's agile, and you have sprints. But you could be doing this in you know, Kanban if you wanted to. Kanban is usually better for, you know, CI/CD. If you're sort of updating it continuously, like the code continuously. But if you have like milestones, then you can be using sprints.
Okay.
So I just made a test one, but I'll just say I'll delete this. But let's say that, yeah, we've got the requirements already, and then just say, you know, add extra counters, change color of the counters, change font of counters. So create issue, add extra counters, and then change colors of counters, and then change fonts of counters, right? And you know how it has, you know, a key here? It says BBDT-7, and then BBDT-8, and then BBDT-9. Now, yeah, if you weren't using something like this, and you created, you know how I was talking about the feature branches? So, yeah, the feature branches. If you didn't use an issue tracking tool, and you know, it's just a local small project that you're working on, then you can have your own convention. But usually in bigger companies, what they have is they have an issue tracking, and it automatically generates, you know, unique identifier for each of the issues. And the way you can easily track it within your code is if you know, name the feature branches as the issue identifiers. So let's go back. So here you can integrate it with the code, but we haven't actually created a repository. So I think that's what we need to do next. But yeah, so before I do that, I'll set up, we need to have a server to deploy the code, right? So before we even, create a repository, let's go over to, and I've decided to use DigitalOcean. So I already have, droplets open, but a droplet is basically just, a server instance. And with DigitalOcean, you can easily just spool up another droplet. So I'll just create one, and then let's call it, say, let's choose Ubuntu Basic, and no, I'll just use a really simple, so lightweight. So let's go with Singapore because that's probably closer to us, right? Because we're in Australia. Yeah. Yep. Now you can put SSH keys, and you could also put passwords and all that. But I'll show you how to do SSH key. Yeah. So at the moment, my computer is already connected to this droplet because my account already has the SSH key on DigitalOcean. But I'll actually show you how to do that. Say you can create a new key and then add in your new key, but I'll show you how to actually create it later in a future step. But in this case, if you already have your SSH key on hand, your public key, then you just copy it there, and you should be able to remotely access the server if you're using SSH from console, right? Yeah, and then so let's create the droplet. So it just has a random name, but we could have named it differently. So let's just wait until that finishes. Now, while it's actually being created, let's go back to say let's go back and actually open up Bitbucket, because Bitbucket is a part of the Atlassian product suite, so you can actually integrate it. And I already have an account for Bitbucket, but I haven't created a repository. So see how it's linked petabyte dev, right? But I still need to create a repository. And let's just call this tutorial. Right. Project name. Tutorial. Private repository. So if it's public, then other people can search up this repository and they can also pull your code. If you give it public access, but if you only limit, say people to download the code if they have the credentials uploaded, then they can still view it publicly, but they can't pull the code, right? But then if it's a private repository, then they can't. They're not able to view the actual repository outside. So I'll just go yes. Yes. So create repository, and this is just going to be an empty repo. So usually it comes with a README, and this is where you can add in your details for the projects. You can forgot what MD stands for, but markdown file. So essentially you'd have to create documentation for your code. So instructions on how to use your code, how to deploy it, and all that instructions. The DigitalOcean would have been finished by now. Yeah. So let's go into there. And now we have an IP address, right?
Yeah.
And I have a console ready, but let's see. Because remember when I was creating this, this server instance, it was asking me if I wanted to use my SSH key, and I already had my SSH key on my account. So all I have to do is SSH and then copy this IP address. Actually, oh, right. So in this case, I can so at the moment, so when you spool up the instance on DigitalOcean, you have a default account on the Linux server, which is root, but you can create your own other accounts after. Since we're just using this for tutorial, I'll just leave it as root, right?
Yeah.
Because there's nothing really sensitive on this server anyway. Now we have a server, and then now we also have a repo that's created, right? So, yep. Now, what you need to do, right, is you need to check if you have Vim. So, Vim is essentially a file editing application on Linux, and it allows you to edit files on the console, right? So what we can do, right, is we'll see if Vim still exists or exists on the actual so it looks like it does exist, right? So I'm just going to make, say, right? So I just made a text file, right? And then if I did vim test text, then I've now opened the file.
Yeah.
And then if I go insert, and then I write down testing vim is working, and then escape, and then save. Oh. And then now I'm checking if I'm checking the contents of the text file that I created. So it says test vim is working. So we know that vim is working now, and it means we don't have to install vim. But if it's bare bones and doesn't have vim, then you probably just install vim. Now we have to figure out if Git is installed on the server. So to check how to see if Git is on the server, we go git version, right? So Git exists, so we don't have to install Git. But if it didn't exist, then you would have to just go through this instructions to install Git, right? So now, since we've created this repository, so let's go source. Let's go back to source. So what we want to do is we want to clone this. So clone, there's two ways to clone it. There's either you do it through HTTPS, and this is the method that you use if you're going to use a password, right? But if you're going to use SSH keys, then you just use this, right? So this is where I'll show you how to make it an SSH key, because it's more secure if you use SSH keys. Because the thing is, people can brute force long passwords, and they might be able to break and hack your password. But if you use an SSH key, then yeah, I could explain that in another video, but it's much more secure than just using passwords alone. So before we actually clone using this, right? This repository or your account, the Bitbucket account has to have the SSH key of the server, because this server is trying to access the repository from Bitbucket, but because this is a private repository, it's not going to give me access, because it's going to say permission denied. So I'll show you what it looks like if you try to do. So if I try to clone this, copy it, and then I'll put it on cmdir, and then paste it, and then enter cloning, and then I say yes, says, Fatal could not read from remote repository. Please make sure that you have correct access rights and repository exists. So it exists, but we don't have access rights because this is a private repository, but we don't have our SSH key. So the first thing you need to do is, so you'd need to check if your server has an SSH key in the first place. So it's usually in a hidden folder. So in Linux, usually when you write the command ls, it shows all the files that are not hidden. But if you go la, it shows the files that are hidden and the files that are not hidden, because it shows everything. But to tell if a file is hidden, it has a dot in the front of the file. So in this case, what we're looking for is .ssh, because that's the folder where the SSH public and private key is. Now, in this case, it's hidden. So what you want to do is you want to navigate to the SSH folder, and then you check that folder. It has authorized keys, known hosts, but it doesn't have SSH keys. So it has, keys that are authorized to access the server, right? Of this server, right? So it has the key of my laptop, which I'm recording this video, to be able to access the DigitalOcean droplet server, but it doesn't have its own SSH key. So now the next step we have to do, right, is create an SSH key from remote access. Right, so let's just go to the instructions for that. Yeah, so the simplest way, there's multiple ways of actually doing, creating SSH keys, but the simplest way would just be h key gen, and then you just create it. So generating file, enter a file in which to save the key, and if you just leave it blank, then it saves it by default in your root.ssh ID RSA, right? So that's the default location. And the thing is, what you can possibly do is also put a password on your SSH key, so it's even more secure because you have to write in the password just to use that public key and private key pair. But in this case, the SSH key is enough for us to do the demonstration, so you don't have to put a password. And yeah, now the key has been generated. So if we type in, because we're still in the .ssh folder, right? So we're still in the hidden folder. So type in ls to view and see how now you have ID underscore RSA, and then you've got ID underscore RSA.pub. You don't want to give out this ID underscore RSA, right? Because that file is your private key, and the ID underscore RSA.pub is your public key. The public key is the one that you want to copy onto Git, right? Or sorry, onto Bitbucket, so that it can cross-check between your device private key, and what it does is, it verifies, is this public key the pair of your private key, right? So you have the private key on your device that's trying to access the remote repository or the remote server, and then the public key is what you give out to the remote repository or the remote server, so that they can sort of do like a handshake and figure out, am I allowed authorization to this this server or this repository? So what you want to do is you want to see the content in ID RSA.pub. So you just go cat ID RSA.pub, and you get like this really long string, this key. Now what you want to do, right, is you want to add it into this repository. So you go to repository settings, and then you go into access keys. Yeah. So here it says use access keys to gain read-only access to this repository using SSH key. So add key, say digital ocean drop tutorial. Yeah. And then you copy this key. Yeah, so notice that I'm using the console on my local computer, but I'm actually accessing DigitalOcean droplet from my local computer. And this SSH key is not the SSH key of my local computer, but it's the SSH key of the droplet on DigitalOcean, right? So I add the key, and then it adds so now I should be able to go back to the upper level. Now let's try that again. Let's now go back to back, and let's clone it again and see if this works now. So it should, in theory, work. So it says cloning into tutorial, and see, now it doesn't have any permission issues. So if I go ls, now I have a folder called tutorial. So cd. So this is a common mistake, right? So people clone repositories and they start working on things, and then when they write down git status or git command, right? It says fatal, not a git repository or any of the parent directories .git, right? Reason being is because the repository is in that folder. It's not on the folder that you currently are on. So you have to navigate to this subfolder tutorial, because that's the actual repo, right? So now, since I wrote git status, it says you're on branch master. Your branch is up to date with origin master, nothing to commit. Now, remember how when we generated this repository, there's a README file and git ignore, right? The README file is there, but if I go, if I type in la, it says git ignore readme.md. Now, best not to touch the .git, because that stores the settings of the actual version control. So if you modify you can modify some of the files in there, but yeah, you have to know what you're doing. But mostly you can modify git ignore and readme.md. So I didn't explain much about what git ignore is. So git ignore is the file where, because you're sharing files with other team members, sometimes you have large files that are generated when you're, say, building the code, when you're testing the code and all that. And when it's running on your local computer, it consumes a lot of memory, right? So you're not going to push those files onto the server, because that's just too much memory usage, right? So the code that you're writing on, so like the say, if you're updating a PHP code, right, or if you're updating JavaScript, right, you only need to version control the JavaScript file. You don't need to version control, say, in Node.js, you have libraries, you've got modules, libraries, and all that. You don't have to version control that, because those libraries are already public online, and you can just initialize, right, the project when you download that on another device, or you can just pull the libraries on another device anyways. So you don't need to version control the libraries, and that's where you write in git ignore to ignore specific files, so the repository doesn't become bloated, right? So let's just look at what git ignore has. So in this case, it's ignoring the node modules. So those are the libraries for like Node.js, and then it's ignoring specific files like exe files, MP4 files, and all that. So these are the files. These assets are fairly large, right? So if you wanted to have a version of these files, or if you wanted to save them somewhere, then you would probably have a different area to save them on. And then the code that you're actually updating is what is stored on the repository, right? Okay, so it's all set up. So now what we can do, right, is let's set up so the projects. So our repository is located on Bitbucket, but this app, right, this project that we're going to work with, right, is on GitHub. So there's different providers, different companies that have their own flavor of Git. So it really depends on the company that you're working for, the stacks that they're using, the technologies that they're using. But yeah, in this case, like you can use different platforms if you want. So sometimes you might have code coming from GitHub, sometimes you might have code coming from Bitbucket, sometimes you might have code coming from GitLab, etc., etc. But it is possible to sort of combine them together if you wanted to. So I'd copy this because there's probably no password for this repository because it's public, right? Now let's go back to here, and then so see when I copied it, it doesn't actually have in Bitbucket it has the whole script. So when I press that in Bitbucket it says git clone and the actual the address of that repository. GitHub doesn't actually it doesn't show it, right? So what you have to do is you actually have to just type it in manually. So git clone, and then it clones. Yeah. So git status. So let me just go through the syntax, right? So let's go back here. Yeah. So okay, I've lost. Yeah, okay, so git status shows you, the modified files in the working directory. So let me just zoom in here so you can actually see. So see how when I wrote git status, you see how this is red? If it's red, it means that the code isn't staged, right? So I'll have to open up another documentation to explaining what is staging, what is unstaged, and all that. So just okay. So I'll just look at this image here. So your working directory, right, is your local device, right? And you can make changes, do different things, right? But it's not going to affect the remote repository. Now, there might be some parts of the code where you're still working on and you don't want to push to the remote repository, but there might be some files or some code that you finalized and you want to put on the remote repository. So that's where you stage it, and you would run the command called git add, right? So git adds files as it looks now to your next commit, right? Now, the reason why this the files that we just added is color red is because it's currently unstaged, which means it's still on your working directory, right? But you haven't actually staged it yet, or you haven't actually added that, right? So that's why it's red, right? Which means you can change it all you want, and it's not going to affect the remote repository, right? Now, if you want to add the file, then you go git add, and then after that, when you want to commit the file, when you commit it, that is not committing to the remote repository. That's committing it on your device, right? So you commit.
Yeah.
So you commit the code on your device, and essentially that updates your local version of your repository and says, "Oh, this is a new commit. This is now the up-to-date code, right, of the your local repo, right?" Now, when you want your version of your code to be the same as the remote, then that's when you push it. So you run the command git push, and that will either. So if you push before you pull the code from the remote, what will happen is if you were working on some code, and then you're changing someone else's code, right? And then there's a different version on the remote, then you're going to have a merge conflict on the remote, right? But then if you pull, right, and then you sort of commit, then you'll have a merge conflict on your end, which you need to resolve, right? So the best thing to do first is what you need to do is pull the code first, so that you have the most up-to-date code from the remote repository, and then you commit your code on top of that, so that you know that there's no merge conflicts because you have the most up-to-date and no one has changed it since. And then you commit your code on top of that, and then you push your code. And when you push your code at that instance, you know that no one has changed it because you sort of pulled the code before you pushed the code, right? So it's a good practice to always, before you're pushing the code to the remote repository, you always pull the code to see if you have the most up-to-date local repository to the remote repository, right? And that will reduce the amount of merge conflicts that you have. Yeah. But that won't always remove all the merge conflicts, because there's some cases where you might have merge conflicts when you're, say, merging branches together, and you have to resolve them in the future anyway. Because when you're integrating code anyway, at some points there are going to be merge conflicts. And that's the reason why. Yeah, that's the reason why you have separate branches and modular code, so that you limit the amount of conflicts. Because if you have modular code, then you're always working on separate parts of the code, right? If you're having a monolithic piece of code, everything's together, then you're always going to have merge conflicts, because your version of the code is always going to be different than someone's version of the code of the same file or of the same part of the code. Okay, so let's move on. So as I was talking before, so git add. Now, if you do git add dot, what that does is it adds all the files that are red, right? If you had separate files, so for example, let's go into hold on. Oh, that's another thing as well. So you know how I did git status, right? And then now it says it says on branch, your branch is up to date with origin master. And you may be asking, oh, why was this branch not up to date, and then now it is up to date? And the reason for that is because when you actually went inside the counter app, right, that's actually a different repository. So you're working on a repository inside a repository, right? So sometimes you can work on nested repositories and all that kind of stuff, but you just have to be careful of, are you working on your repository or are you working on someone else's repository that you cloned inside your project, right? So that's when it becomes confusing. And yeah, so in this case, I can't show you because usually, or what I can do is this, right? So let's say I make a separate file and call it test.txt, right? ls. Now I'll go git status, right? So in this case, yeah, now you see both of them are red because both of them are modified on my local device, but I haven't staged them yet. So if I wanted to stage all of them, then I could go git add, right? But I'll show you what it looks like when I go just stage one file at a time. So if I go git add, say, I'll do the counter app. Yeah, so it says you've added another Git repository inside your current repository. Clones of the outer repository will not contain the contents of embedded repository and will not know how to obtain it. Actually, what I'll do, right? Yeah, so I'm just trying to, and that's another thing. If you're stuck in the middle of something, it's good to look at forums. Yeah, so it says just delete the git directory and it will be all. So if I just went into the counter app, right, and then ls and then la, see how it has .git. If I just go rm rf.git, so rm.rf is just a command to delete, files. So rm is to delete the file, but then -rf is to recursively delete the files inside that folder. So in this case, we want to delete so ls. So if I go git status, yeah, so see how it no longer says hold on. Yeah, it no longer has this this message, right? Because when I deleted that .git, it deleted the the repository or the reference to the repo of the counter app, and now it's referencing the parent repository, which is the one that we made. So if I go back out, right, I go git status. Yeah, so yeah. Okay, so let's just do this for instance. So git so what I just did then, right, was if you accidentally staged a file and you wanted to unstage it because you wanted to add changes to it before you commit, you can just run the command that that it mentions to unstage, and then now it's unstage. But let's try git add all. So if I did git add all, then git status. See, now it's added the whole thing, right? And notice how it doesn't give me hint warning anymore because I've deleted the actual repository of the the nested repository. Yeah. So it's just normal files now. So going back to that diagram, So we've added, now we just need to commit. So this is the command that you usually run. So where is git commit? Yeah, so git commit -m. So git commit -m, and you add a message. You describe the message. So you describe what you did. So git commit -m, created a new counter project. Right. So you press enter. And yeah, at the moment, because when I wrote down git commit, it didn't do anything. So if I go git status, or actually git log shows you, if you go git log, right, it shows you the commits. So initial commit was made by when you generated the repository, and all the branches are currently at the initial commit, right? But in this case, it doesn't know who I am, right? So it can't access this repository. So yeah, so I have to add my credentials. So in this case, so I'm just going to test something. Because I've used my email, but remember how I had the SSH key? So if I have my email and I have the SSH key, then it should be able to commit. Yeah, so there you go. Because I have my email, now it knows whose account I'm using, right? And then when I ran the commit message again, it was able to create it because now it has reference. If you did the HTTPS, right, then it would ask you, please enter your credentials or please enter password every single time, right? Unless you actually do git config global and then user.password equals this, right? And then it would automatically, use your password. The only downside is if someone also has access to your server, they could easily just look at your global configs and see what your user password is, right? So that's the one reason why you have the SSH key, so that they kind of have access to it, even though they don't have the if they don't have the SSH keys, right? So ls git status, and then now it says on branch master, your branch is ahead of origin master by one commit, right? So because we know that no one has worked on the master branch and no one has made any changes and all that, we don't have to pull from the master because we're the only ones using this project, right? So what I can do is now I can go so git push. So if we go push. Okay, so it says okay, so right, that's another thing. So sometimes this happens because remember how now I'm able to pull the code, but why can't I push the code, right? And do you know why?
Why? Yeah.
Because let's go back to access keys, right? Remember, this is only read only. So for security reasons, you can't modify this SSH key. So access key can only gain read-only. So this is only read-only access key, but I think what we'll have to do is probably have to go to the, personal settings, right? And then actually, so you would have to actually go to the personal settings bit bucket, right? And go to the SSH keys. And so the access keys only gives you read-only access. This one gives you read and write. So when you add the key, let's go back up and recopy this key, right? So add key. So tutorial, add key. Someone has already, so you'd have to change. So someone has already added that key as an access key to our repository. So in that case, we'd have to go back and we'd have to delete it. So let's go back. Let's go to repository settings, access key, and delete, because or else we can't put the SSH key. Personal settings, SSH key, and key, paste, motion, droplet tutorial, and then add key. Now we have, so this should have read and write access, right? So if we go back to here, the console, it should give us the ability to push. Let's see if this works. Yep, it's working. It's working. Yep. So when you go git status, now on branch, your branch is up to date with the origin master. So let's look at the repository here now. So now, see, now this appears. Actually, sorry, that is the repository, sorry. But see how now we have an extra folder, counter app, and we also have that test text. So now this is on the repo, right? Like our tutorial repo, right? And you can spool up another server instance and then pull this code on another server instance. Or you can have a local device, have it set up locally. You can have a VM, a virtual machine on your device, and then work on it locally, and then have the same thing happening, and then people can work on different things, right? Okay, so that is that. So what are we up to now? So we've set up remote access SSH, and we've created a project, pulled a server. Now we have to create the branches, right? So let's go back to the commands. And another thing that I should have showed you, but I'll show you later on as well, is git diff, right? So git diff, actually, what you can do is you can go git diff and figure out the changes. So what git diff is it shows you the differences between different versions of commits. So you can, for example, git status, it's up to date. So if you go git log, now we have two commits. We have created a new counter project initial commit. So what you can do is and the identifiers for each commit is usually in like hexadecimal, or this huge as identifier. If you go git diff and then, because this is the most current version, if you want to see the difference between the initial commit, then and then see how the green shows you the differences between the versions, and then so the green with the pluses shows you the additional lines of code that you added, and then if you like deleted some files, then it would be red and it would be minus instead of the plus. So it would show you what files, and this is just the React.js dependencies and all that, right? So let's just I'm just going to clear this to make it clean. So now what we want to do is create branches. So at the moment, if we go git branch master, so we're on master, right? If we go git branch -r, I think that's what it is. Yeah. So see how here it's green and it says master, and then here it says origin head, origin master, right? So this is the branches on the remote repository, and this is your repository, right? So in this case, the origin head is pointing to origin master, which means the commit version that is on the current commit that is currently being selected, right, is origin master. But sometimes what you can have is the origin master is a couple of commits ahead, and then your origin head is actually a couple commits behind, and that's when somebody might have just checked out a previous commit and is working on that instead of the master, right? But you'll see that later down the track. Now, what I'll do is, remember how in okay. Remember how we have the different tasks, right? Now we can actually create the branches. And before we make these feature branches, we have to sort of set up we're going to have to set up the actual Git flow. So where's that diagram? Yeah, so we're going to have to set this up, right? So we've got master now. So we'll make a development branch, right?
Yeah.
Yeah, so if you go git branch, see now there's development, an extra branch, but you're still checked out in master. And if you go git branch -r, it doesn't exist on the remote repository because you still have to push that branch. Now, you can do it this way, or there's a way on the actual repo, you could actually create the types of branches. And yeah, so I'd probably recommend to create the branch on the actual Bitbucket first, so it's set up correctly. So for example, we make development, right? So now you have two branches, and then from development, we can create feature branches, right? So yeah, at the moment there's master development. Now what we can do, so from development, we want to create these feature branches, right? Yeah, so because I've already created the development branch on the local, and then I did git pull, now it references the branches. Yeah. So if we go git, check out development. So at the moment, I'm currently on master, but then if I go git checkout development, it switched to development. So if we look at the files, it's still the same thing. But let's say in development, I were to change. So at the moment, the test.txt doesn't have any content in it. But let's say if we edit it with Vim, and then, right, we are on, right, and then I save the file. So we are on development branch, and git status, we modified that, git commit, git add, git commit, git status, then git push. So this is what I want to talk about. Because this is the first time you're using the branch, right? You can't directly push straight away because the new branch isn't tracked by the remote. So if you want to track, the upstream of the remote repository, and you want to sort of keep it in line with, your local repository, you'd have to run this. So you'd have to run this command. There's a different variation, like there's an older style of doing it, but you'd probably best to just run what it says. Sets. So let's see what it does. It's gonna push the latest code, and then now say look at this. It says to bitbucket.org, better bytes pty ltd tutorial.git. Now it says branch development set up to track remote branch development. So it's now in line. It's now in sync with the origin. So if we go git status, right, or git log, I should say, see how, so you've got head. See how head is now on development. So setting up development branch, and then the origin development, which is here. So let's look at here, right? So let's refresh this, and then let's go back. Yeah, so let's look at this. So 2 minutes ago, right, we are on the development branch. So see how it saved, the change, right? And if we go back to the master, right, let's go back to master, and if we look at the test.txt, there's nothing on there. And that's because we pushed our changes to development, but we didn't push it to master, which I'll show you how that's going to be done later down the track once we actually make the changes to the actual React application. So development, we made our changes. Now what I want to do from development is create branches from there, because you don't want to directly work on development because you might have multiple people working on development. So from there, you would need to create so another branch, right? So create branch, let's say feature. Oops. So I'll just show you something. Feature branch naming conventions. So there's different ways you can name the feature branches, but usually there's a convention that people use. So see how you can go feature, say, oh yeah, there you go. So another reason why you want to create it on Bitbucket or whatever, whatever you're using. So if you're using GitLab or GitHub, then you want to create it there because you can automatically create, the branch name. So if you do feature / you can call that feature whatever you're using. So in this case, we're using say BBDT-7. So BBDT-7. But the reason why I'm saying this is because if you ended up making this branch on console, then you could misspell it, and then you could have issues with the naming conventions and all that. So what I would do is, with the issue tracker, you could have the long name, so add extra counters or something like that. But the thing is, because you're using an issue tracker anyway, you can just leave it as BBDT-7 because you can probably reference it within your issue tracker anyway. So you go, and the thing is, this see this diagram, it's saying that it's merging, or it's taking the version of the code from master. So the thing is, you don't want to directly work off of master, because remember how that's the issue with a lot of tabs. Yeah, here you go. So you know how here, so you've got master and then you've got development, but then the feature branches aren't working directly from master. They're working straight from development, right? So what you need to do is you need to change it, and you need to say, oh, we want to work from development, right? And then create that, right? So now you have another branch. Now what we need to do is go back to the other ones and prepare the other branches. So So now we've got BBDT-7, that's add extra counters. Now let's go change colors of counters. So create a new branch. Let's feature branch from development and see how now you have the extra feature, right? You can make, another branch of another branch of another branch. So you can play around with it and have limitless amounts of branches off of other branches. But in terms of organization's sake, then you want to limit the amount of branches that you have. So from development, and then this would be change. Oh, sorry. BBDT-8, right? So create that, yes. And then let's make another one. Now, when it's asking about checkout in SourceTree. SourceTree is a application that you can set up on your desktop to, give you a visual layout of your repository. There is a way to. So if you go to say commits, that does show you sort of a graphical. If you go say. At the moment, it doesn't really show you, how they're connected, but eventually when you have more commits, you'll see a graphic on the side, or maybe it's in a different option. But yeah, you usually see how the branches connect and how the commit nodes are represented. So you would see something. You would see something like this, like a diagram like this, and how the branches are connected. But at the moment, it's not really important. So BBDT-7, BBDT-8, and then let's make another branch. BBDT-9. Feature. And development. Yeah. Okay. Okay, so we go back branches, and we've got our 3 features from development. So let's go back here, and then if you go git status, right, or git log. You don't have the other branches. So if you go git branch, you only have 2, and now we're checked out in development. But if you go git branch -r, notice how here it just says development master, but you don't see the other branches. That's because your local repository keeps a reference of what is on the actual, the actual remote repository, right? But the thing is, if you don't pull, or if you don't fetch the latest information from the remote repository, then you're not going to have any up-to-date information about what the extra things that just happened. So the extra things that just happened was that we created these extra branches, right? But it's not actually showing. So we're like, oh, how come there's no extra branches? So there's 2 ways of updating your local repository. One way is to pull, which will fetch the remote, the metadata and all that about the remote repository. And it'll also pull the actual, up-to-date, files and data in the actual, branch that you've checked out, right? Now, if you don't want to do that, because sometimes you're currently working on code, and once you pull the code from the remote repository, that will populate what you're working on. So it might interfere with what you have already set up, right? So if you just want to, details about, what branches are there remotely, then what you can do is just go git fetch. Git fetch, right? So git fetch will just get the information. So see how it says new branch, new branch, new branch, and then now if you go git branch, but the thing is, it won't pull any new code from the from the remote repository. So you don't have to worry about your code being interfered with. So if you go git branch R, right? So now you have a reference of the remote branches. Yeah, so you have the references of the remote branches now, because now you actually fetched the metadata of the remote repository. Now, so let's go into let's go git checkout feature. So now what we want to do is we want to work on, so before we start working on these features, what would usually happen is, so as you're doing the requirements solicitation and analysis and all that, and then you create your, you do your planning, and then you plan out your sprints, and then you usually have, a backlog list of tasks throughout the whole project. And then from that backlog, you would sort of break that down to, a sprint backlog. And so if, for example, here, let's say I create sprint 1 and then add this one, say sprint 1, let's say I'd put 2 in one sprint, and then create another sprint 2, and then, put that for sprint 2, right? So that means with the feature branches that I made, right, the BBDT9 would be sprint 2, but then the BBDT7 and the BBDT8 will be sprint 1, right? And let's say, so we haven't assigned it to anyone, but we'll just, assign it to a team member, and then assign it to team member, and then, so, and then let's start the sprint, right? So start date is today, and then end date, so that is 2 weeks from now. So by default, it sets it for 2 weeks from now. But you can change the length of a sprint, or increase, decrease, and we'll just say add extra counters and change colors. So maybe let's do it in 1 week, because we'll probably finish it. So start, and now, so we don't have to do, like say if there's 2 team members that are working on the task, you can assign this to another. Say I'll assign this to you, Earl. But so what we can do is, I'll say add extra counters, right? So in progress. So that tells everyone that I'm actually working on it. And while that's, in progress, I go, so check out B, and then I just have to select number 7. Yeah, so it says branch feature BBDT7 set to track remotes. Yeah. Okay, so now. So it's up to date. Let's look at that project again. So see how, remember I was talking about the readme.md? When people are making their applications, right? They need to write down the commands to run so that you can, test your code, you can run your code, you can, build your code, and so on and so forth, right? So in this case, I'll have to go into counter, cd counter.app, right? And then, so the thing is, this, when you go http /localhost, right? That's assuming if the code is on your local device. But remember, we have this running on a remote server, right? So if we go npm install, that will, okay, so npm is not found, right? So what we need to do is we actually need to install node. So that's another thing as well. Yeah. So because I'm in root, then I don't have to go sudo, right? So I just have to go app install npm. Yeah, so app install npm. So that should, and then just press yes. So that will install the packages, libraries, and all that. It'll install node and npm. Usually to make sure that it's all up to date, you'd probably run these commands apt-get update, apt-get upgrade, so that will update the repository, the library repository for node to be installed from. So if it's not up to date, then it might be installing an older version of node. Yeah, so we'll just have to wait until it finishes installing. So how are you finding it so far? Is it it seems a bit like complex and overwhelming, but
yeah, but I think it might help when we start handling projects, because it might be, this can be efficient for us.
Yeah. So the thing is, when you're working in groups, it's like, at first it is difficult to set up the environment and the version controls and the working together in a team with the tools. But once you get sort of the hang of it, it's sort of like playing basketball, right? When you play basketball, you have a team. First, you're going to get used to playing by yourself and shooting the hoop and all that kind of stuff. But then eventually, you're going to have to get used to, playing a specific role within the team, and then how to pass the ball to another team member, and so on and so forth. Yeah. So.
Yeah.
Oh. So apparently it didn't. Maybe let's try this. Okay, so if that didn't install, maybe this is where you have to go. Oh, that's another thing as well. Depending on the version of Ubuntu that you have, sometimes the commands that you actually have to run to install certain tools, libraries, so on and so forth is different. So that's probably why when you're following a specific tutorial, and then the software doesn't actually say properly, then that's probably because of the version of the operating system.
Okay. So like, do we really need to use like Linux terminal for this?
Well, so there's a reason. So there's a big reason why you'd use the Linux terminal, because you're hosting the server, the droplet server from DigitalOcean, right? Linux usually comes in two flavors. They usually come in the desktop version and the server version. And the server version is usually console-based, but the desktop version usually has a GUI. Now, the reason why the server version is usually console-based is because it's lightweight, and you can easily access it remotely on using a, just SSHing using a console, right? And it doesn't lag that much. If you end up remote accessing your server and you enable the GUI, the user interface, then it's going to be really slow because you're trying to work remotely, and it's constantly streaming the the screen to your local device, and that's why it's really ineffective if you're gonna. So the thing is, if you want something with the best of both worlds, where you want the user interface, but at the same time you're working remotely and you don't want it to lag, then what you could do is set up an environment on your local device, right? And set up your, say, IDE, your Visual Studio Code, right? Or Sublime, or Notepad++, or whatever you use. Set that up, but also set up a plugin or a library that allows you to remotely connect to your server and access your files, and then that way you can load your files remotely onto your IDE on your local device. So you can still use, and that's what I was going to show you before. That's the reason why I have, or actually not before, but I mean that's what I'd eventually show you. So I have Visual Studio Code open, and there's a tutorial on how to connect, so remote development over SSH. So when we start programming, you're not going to change and update the code through the command line, because that's just going to be very tedious, because even with using Vim, it doesn't have the proper syntax highlights, and also the error checks and all that. You can't have error checks on, like, it's hard to have the error checks on actual console. So it's better to have the syntax checker on your actual IDE on your local device. But I'll show you how that works. So so now that's up to date. Let's go back to, hold on, did I just, so I guess the instructions was, so apt install. So now we go node. Yep, so now it's version 10.19.0. Now let's do that again. So now we know that node is installed. So now we have to set up the application, and we write down npm install. So let's just see what npm install does first. So it would execute the package.json. So if you look at the contents of package.json, it has in the JSON in JSON format, it has scripts, and then it has start, build, test, eject, right? So yeah, so when you run npm install, what will happen is it will install these libraries. And remember how I was talking about how with the git ignore, you ignore the node modules. In the node modules folder, these are the libraries that will actually be installed. So because they're already publicly available, you don't have to keep a reference or a copy of them on your your repository. All you need to do is install it, and then it's going to pull the libraries in. So let's just do that. So npm install. Right. Oh, in this case, yeah, see how before, right? I did. So it's actually using, yeah, it's actually, so apt install, oops, apt install np. Yeah, so I also had to install npm. Now, this is just doing it directly on the server, but sometimes you might want different versions of Node, or sometimes you might not want to install that at all, and you're working on the same server, right? So if you have like different applications, right, then what you could do is create Docker containers to encapsulate and modularize your system. So if you have a container, then you can have an environment for Node.js in that container, right? And then if you have another container, you can have, say, WordPress instance, or Laravel, or a different type of application, or a different type of stack. So for example, if the software that you're using needs, say, you need a different OS, right? You need CentOS, and you're using your droplet is Ubuntu, right? Then you can create a Docker container that has CentOS OS and run that specific application within that Docker container. So it can still run within your general server, but it's within another container within your server. Yeah. But yeah, that's later down the track. That's even more advanced when you start working with containers, because you can work with repositories within containers. You can link releases of your Git repository to those containers, and then essentially it's like whenever you might have a live server that has a container that's connected to your release, and then while your developers are working on a development server, and then they push the code to the development branch, right? And then the senior developers, they verify the code's working, they test it and all that, and they send it to the test servers, and then it automatically gets deployed to the live server. And that's how essentially what they do is they create a CI/CD pipeline where people are committing code on the development side, and then they're pushing the code, and then you have build servers that automatically test the code and integrate the code, and then once it passes all the tests, then it pushes it directly to the live server. It pushes it and deploys it and builds it, and then it builds it and then deploys it, and then it deploys onto the live server, and then it seamlessly updates the system on the client end. So the client themselves, they don't see any difference, right? And they don't see any downtime, but it's continuously updated as developers continue to work on things. So what did that do? So what did the npm install do? So what it did was it created a we haven't even been up to that point yet. So we've set up, we installed npm. So npm version. So now it's 6.14.4. And then if you go npm install, so now you're installing the actual project, and it's installing all the dependencies. Yeah, so now that's finished. And then, so before we just had public source, and now we have node modules, right? And also the package lock. So the difference between package.json and package lock is that so when you're installing the libraries for the project, sometimes those libraries have their own dependencies as well. So all that, all of those are the dependencies of, so libraries have dependencies on other libraries, which have dependencies on other libraries, and so on and so forth. So you can really have a nested dependency list, right? Now, next thing is you go npm start, right? So we go npm start. It's currently running, right? But now see how, so it's running. See how here, if you want to open it, you would go localhost 3000. But the thing is, remember, we're running it from DigitalOcean. So what's the public IP of DigitalOcean? It's 139.59, so on and so forth, right? So let's copy that. So here it says localhost, and I'm assuming this probably won't work because the ports are probably blocked on the outside, right? So if I did that, so there you go, it works. Yeah, so I'm accessing the app, right? So see, here it says HTTP localhost port 3000, but here I'm using 139.59.109.39, 3000. And yeah, that's working. But if I go Control C, now it's no longer running. So if I because this is React is basically a front-end framework. It's still functioning, right? Right. But if I refresh it, yeah, now I can't access it because the server is not running. So if I go start again, yeah, then let's refresh this.
Yeah.
And also another thing is there's plugins that you can use that automatically say restart the server once you make changes. So for example, when you make changes on this, right, in code, then it updates automatically, right? On when you're running it in the actual, the browser, right? So now what we want to do is, so if we navigate into the source code, and then we look at the app.js, so there's counters, right? And then essentially if I were to create another counter, I would just add in another line, right? Now I'm not going to want to edit this on the console because it's going to be tedious, right? So that's where I was talking to you about before, is where I set this up for remote access, right? So that's where this comes in, right? So we now just need to look for, cancel. We now just need to look for the plugin. So remote. Now, see, that's one reason why sometimes you might want to work directly on the actual server itself. So while this is loading, so unfortunately I might not be able to show you how, the remote access works on this, but what I can do is just work directly here, right? And then say, for example, so what I usually do, right, is if I want the server to run and also I want to make some changes as well at the same time, I usually have two consoles open. So let's start that. So there's console 1 and then the second console. And then let's say the first one, we go npm start. So that the first console is running the the app. Yeah, so the app is now running, and we know that there's 4 counters, right? And then this one, what we can do in this console, say, let's go src. Let's see if this is actually connected. No, it hasn't connected yet. So that might be permission issues. Like I might have to look into, seeing what the issue is with SFTP, because sometimes some ports are also blocked, like, and some protocols are blocked. So you might have to figure out, if it allows FTP to be able to access the server. But for now, because the main prerogative is to demonstrate how Git works, now what I'll do is I'd go vim, so edit the so let's add another let's just, by default, let's add the defaults for this counter as 1, and we'll save that. No. Oops. Okay, clear. Oops. So see that how I saved it, and then look how it updated, right? Yeah. So now if I go git status, right, it says I modified
app.js.
JS, yeah. So I go git add, or first what I can do is go git diff, right? And what git diff does is it looks at the difference. So see how here it says I deleted a line, right? Because I actually what I did was I added a comma, right? So when I added a comma, what that's actually doing is it's actually deleting the previous version of that, and then it's creating a new one with the comma, and then it's adding the additional line that I put it in. So yeah, so that's the difference. Git add, git status, right? Now that's staged. Then git commit, added extra counter, right? Right, and then git status. Your branch is ahead of original feature db-dt-7, and let's look at the, let's cross this out. So add extra counters, right? So git push, git status. So it's up to date now. And then if we go back into, let's go back into the code. Where is it? Yeah. Okay. So added extra counter just a minute ago. So yeah. Now, so once I've done that, right? So we know, and we've tested it already because it's currently running, right? And as you can see, there's an extra counter, right? So, and there's additional things you can do as well. So like usually before you merge with a development branch, you'd have your own, test framework that you might have automated tests, or you might have, say, unit tests and all that. You might have a automated test framework that tests the front end. So you might have, functions that tests, button presses, right? But it does it in the background, and it checks to see, is this counter working, right? And if it isn't, then it gives you, it sends you a notification saying that this test failed, right? So that's another additional things that you can add to verify that you've actually completed implementing that feature, right? So what I can say is that because I've done this, right, I can say usually sometimes what they have is an extra column saying review before it's done, because you have to review it first. but in this case, it only has done. So what I'll do first is, instead of putting it into done, right, I'll create a merge request, because yeah, I'll create a merge request. So pull request. So when you create a pull request, it means that you want someone to verify that your branch, like that your code is working, and then you create create pull request. So bbdt7, and then you want to merge it into development, right? So delete feature. So it says delete feature. You have an option to delete it, or you can leave it, right? So you can have a history of it, but it says delete feature bbdt-7 after the pull request is merged, and then add. So I would probably go. At the moment, I haven't added you onto this team, so I'd probably just there's I can't add myself as the reviewer, but if there was another team member, then I'd probably be able to do that. And yeah, you can just add extra details on that. So create pull request, right? And it's taking some time. So yeah, so welcome to the new pull request experience. So someone else that is assigned to review this code will check, oh yeah, you added an extra line of code. I'll review it, add comments to it. I might say, oh, I've tested this and there's a bug on it. Please fix this bug, or something like that. And if I, as the reviewer, says, yeah, this satisfies, the requirements, it passes all the tests.
So like they can also like modify that JS file.
Yeah. So so the person who's reviewing the code, you could also modify it at the same time as well, and you can say, oh, you forgot to add comments. In this case, add a comment. It's like maybe you can add it, say here, right? And then you can say you
can put this line of code, or and use this.
You should have done this, and then you could put a code. You could put a code snippet. So you can put there, and then you can say ID 5, and then value 0, because the default value is 0, right? And then say, for example, you accidentally put a 1 and you made a typo, and then the person who's reviewing it says, oh, you should have put value 0. Then and then save. And then after that, you'd probably just so you can create like a task for it. So create Jira issue to notify the person. But yeah, if everything, just say that you made the changes again, you made a commit, and then you made another pull requests, right? And then say the pull request was you were happy with it, and you said, oh yeah, everything's great. Then the person reviewing it says, I approve, right? So when you approve, then you can press merge, right? So when you merge, right? So the source of the code is BBDT-7, and then you're merging it into development, right? So yeah, see how, look at this. See how it's linked to an issue here? So it says BBDT7, add extra counters. So it recognizes that this feature is actually this task. So if you go here, done, and then you merge, look what will happen. So merge, pull request, merge feature, yeah, so yep. And I think we have to refresh this. See, yeah, see, now it's done, right? Because Bitbucket updated the board, right?
Yeah.
Now, if you look back at branches, you still have that feature, right? Because you didn't delete it, but it merged the code together. And see, look at this. So this is where the different versions. So this is how like add extra counter. So it's at 2 branches, development and feature, and then it merged over here, right? Because here, this version of the code was only on BBDT-7, right? But it wasn't on development branch. And then when you merged it, now it's merged, right? So now, say another person may have been working on the other part of the code, and then it would have had a separate branch of this, right? And then what the senior developer would have done was he might have just merged all of the code together at one point, right? Okay, so now that's now that's done. Now let's say that you started to do change color of counters, right? So now let's start that task. So here I'm still in Git branch. I'm still on feature BBD T-7, right? Now the thing is, you can jump from feature, as in if you check out feature BBDT-7, right? If you're checking out as a new branch, right, then it will take the existing code of the current branch that you previously were on, and then it will copy it over to the new branch, right? But if you're jumping from, say, feature BBDT-7, right, and then you're gonna go git check out feature -8, right? So you switch branches, but if you look at the code, so let's look at app.js. The code that was on the other branch is no longer on the change colors of counter, right? Because this branch still has the version of development previously, right? So I'll just explain by the diagram in terms of So here it says 4 branches. Feature VBDT8, right, is only up to this version, and it doesn't have the extra counter added in because that's over here. So that means for this to have this version, you have to pull the latest version of development to this, right? But I'll show you something. So I'll do that later. But what I'll do is, instead of pulling this code to the branch here, right, BBDT-8, instead of getting the latest code, what I'll do is I'll still work with the same code, but then I'll merge it later down the track, so you'll see how that works, right? So so let's say to change the color, you're gonna have to change the CSS file, right? So in this case, oh wait, it's actually in components, because how React works is that they have say JavaScript code for each individual module, right? So counter, right, is that object that you want to change. Oh, no, cat counter.jsx. Yeah, so in this case, it looks like HTML code, but it's not actually HTML code, because it's just yeah, it's using the React framework to make it like it's like, it allows you to see it as HTML code, but it's actually its own language, like JSX, right? So, but then later down the track, it sort of compiles down to the HTML code anyways, but it uses the JavaScript to do that. Now, okay, so in this case, where do we want to change the color? So button here. So on click, so it's still running in the background, right? So let's say if we look back here, it's changed back to 4, right? But let's go vim counter . So that's the row, version button. So I'm just trying to remember the style. see if that works. This is probably not the proper way in actually changing the color, but no. So we've got yeah, that's another thing. Yeah, so I'm not a full expert at React, so, but I can figure my way around. Yep, so that should work. Blue is not defined. Ah, right, because I didn't put the quotations on it. So, yeah. Oh, so I actually changed this. So, which means I might change the color of that yellow 0 and see how it looks. So span style. Blue. And then this should update. Yeah, see, now it's blue. So it's, yeah, pretty ugly, but yeah. Okay, so now that's that. What we can do now is git status, git diff, and you can see the changes. I changed in this line, and I changed it in that line. In this case, here, it didn't delete anything because I didn't add to the syntax of like the line above it. But with this one, because I added to that line, it deleted that line.
Yeah. So whatever line you modified, that's what the git diff shows.
Yeah. So that's the thing, because sometimes what can happen is you're working on code for hours on end, and then you forget which lines did I change or which lines did I update. So you use git diff to remind you that this was the previous version, and then now that's the new version, right? And it's helpful because sometimes you're bouncing around different files. And you might have multiple nested folders, and then you're like, wait, I've been working on this for 1 hour and I've made a mistake. Now my code is not working, and you need to backtrack, what code did you change? And this is very helpful in that. And it allows you to sort of backtrack when you're trying to, say, debug your code or trying to fix up your code if you made a mistake. Yeah. So now that's working. So git status, git add, git commit, then m. Oh wait, hold on. So just, And sometimes you can be working on hours as well and you forget what branch you're on. So just in case, if you commit on the wrong branch, you go git branch, and then you check what current branch you're on, because you don't want to push the, the code and you start making changes and then you realize, oh, you're actually working on master, and then you realize, oh, you're going to commit the code to master and you're gonna stuff everything up because you worked on the wrong branch, right? And that's happened a lot of times. And I sort of had to, people had to sort of fix it, change it, and make workarounds. Yeah. So now we can commit. Changed color of add button and what do you call that? Text area. Yeah. So change color of add button and text area to blue. Okay. Git status, git push. Status. Now let's go back to Git, and then let's refresh and see what happens here. So have a look at this. So now when I made that commit, right? So this is the recent commit that I just made. So change color, add button and text area to blue, and then the branches look different because the other version is like over here. So that's the one with the extra, the extra buttons, right? So yeah, or sorry, the extra counter, that feature of branch, and then this one is the different color, right? So now what we want to do is that we want to combine the two features together. So this feature doesn't have the extra counter, and then this feature, the feature branch for the extra counter doesn't have the different color. So the thing is, you don't have to do double the work just to update the this feature branch that has the extra color but doesn't have the extra counter, right? Because all you need to do is just merge the two, and then you get the update of the change in one feature, and then you get the update of the change of the other feature, and then you combine the two updated features, and then it sort of cuts the time in half instead of trying to duplicate the code and then adding it on top, right? So we'll do that process again. So pull request, create a pull request, and then from feature 8. So yeah, that was feature 8. From into development, right? So we merge it into development. Then reviewers, let's say that I'm happy with the code, or yeah, let's make a pull request. And also you can add attachments, like you can take a screenshot of, you can take a screenshot of the like the app actually working, so people can see without actually having to deploy the code, because someone that's checking from their phone might not be able to test the app because they don't have the ability to build and run the Node.js app on their on their phone, or they are not able to access the actual app from the live server, or for some reason, right? So sometimes you might want to add photos to show, oh yeah, it's working. Now you create a pull request, right?
Mm-hmm.
And then, yeah, and then load comments, and then I add a comment, and I say it's a weird choice of color, but I like it, right? Save. And then once everything is okay and it's approved, then you approve it, and then you merge it, and then transition to done, right? And then when you merge it, so now this updated, and yeah, it's completed. Okay, so I didn't have to drag it to the done. It just automatically said, oh yeah, it's done, because it took the reference of the BBDT8, right? So now it's all done, right? So that means the whole sprint is finished, because we've finished all, the tasks that was in the to-do list and backlog, right? Mm-hmm. So now we can go complete sprint, right? Actually, cancel first. We can look at the insight, see. Oh wait, yeah. I think that was like a complete sprint. Yeah, so that's completed, and yeah, there's no items in the backlog, and now you have sprint 2, right? And you can revise what you need to do for sprint 2, and so on and so forth. So I probably won't go through that, because it's probably like sort of redundant anyway. The steps pretty much the same. You would pretty much just you start the sprint, and then you check out in that branch. Now there's one thing I might show you. So let's go to commits, and let's expand this. So yeah, so here you see how like the diagram progresses, where the first feature, the BBDT7 was merged with develop, and then the BBDT8 was merged with develop. So at this point of the timeline, this version of the commit has this version of the code, BBDT7 and BBDT8. Now let's actually test that. So remember, one version of the code, right, has an extra counter, and this version of the code has blue, right? So if we were to go git check out, say, development, right? Yeah. So now look at how, like, now you're going to question, oh, we made these updates, why isn't it up to date, right? Because remember how the version of development on your local device doesn't have the up-to-date commit of the remote repository, right? So if you go git log, right, it's only up to the setting up development branch. But if you go git fetch, because if I did git pull, then it will move the development branch up to the latest development commit, right? But if I did git fetch, this is what will happen. So git log. So now the head development, which is the remote, sorry, actually, so it says your branch is behind origin development by 4 commits and can be fast forwarded. So git, if you go git log, it only shows what is on locally on your local repository. But if you go git log origin, right? Actually, git log origin development, right? Yeah, so git log origin, right? And you have the commit that merged, BBDT8, that's origin development, and then BBDT8 is here, and then BBDT7 is here. But the thing is, the head development, which is a local, where your repository is on your local device, which commit it's currently at, is over here at setting up development branch. But the latest is up here, which is at, when it merged with BBDT8, right? So what we need to do, right, is actually go, git pull, right? So if we git pull, that should move head development up towards origin development to the same commit. So git pull. Yeah, and then now git log. So now we're at here. See? And see, now look at the application. It merged the 2 versions, and now you have an extra counter with the setting 1, but then you also have the up-to-date color, right? So yeah, so the thing is, if you didn't use version control and you were working on the code and one person only had the code and you wanted to sort of work on it at the same time, the other person would have to wait for the first person to finish programming before he can start working on it, and which is very time consuming because only one person can work on it at one time. But if you have 2 people working on it at one time, then it's relatively easy to make changes on the fly together. Yeah. And then now that we're there, so I think pretty much. Yeah, so we've done features. So I'm just going to leave the font, the changed font, because it's pretty much redundant. So we've made changes to feature branch. We merged feature branch, tested the code. We merged. Okay. So now we need to merge development branch to the release branch, right? So what that would be is okay, so let's do this. So let's go to branches. At the moment, we don't have a release branch, so we have to probably create one. So release, and that release branch is from master, right? So I guess what we can do, let's make release, right? And say, let's say 0.1, right? So create, yep. So we're making that from yeah, the master branch. And then what we want to do is, so let's have a look at how it looks like. Actually, let's go commits. So yeah, at the moment, so what's release on? So release is very behind. What we want to do is merge development, because just say at this point we're happy with the progress of the app, and we want to say, oh yeah, the application is at the point where we want to release it to people, right? So create a pull request, and then create pull request, go from development to release, and then say yeah, okay, pull request, and these are the list of commits that you're adding to that, you're merging to that release, right? So in this case, yeah, here it's adding an extra counter, and here it's changing. So it shows all the changes, right? From app.js to counter.jsx, right? And you say, I approve this, and then you want to merge it. Yeah. Merge. And then it's merged, and then you go commits. So yeah, now there's you see how the Git flow is growing and it's progressing. So you've got here, so this would be your development branch right here, and then here are your feature branches, right? And then here is that release branch, and this is so this would be release 0.1, right? And then that's the first release that you're going to release to your customers. And then if you want to make your if you want to make that code publicly available, if this was a public repository, and if you want to make that publicly available on your master branch, and that's what you want people to download, then you can go merge it with master as well. So create pull request, then you take release 0.1, and now you merge it to master. Create pull request. And then maybe.
So yeah,
yeah.
So the two things that we need to use are Bitbucket and Jira.
We can use it, but because the reason why I'm using it is because Bitbucket integrates with Jira seamlessly, right? But
what are other platforms that integrates with Jira?
Like there's a lot of integrations. Like you don't have to use Bitbucket. You can use GitLab. You can use GitHub. Yeah. So, but the thing is, because Bitbucket is Atlassian and Jira is Atlassian, it has easy integrations. Sometimes it's a bit more complicated integrating different tools with different platforms, because you might need a third party app to integrate the two tools together, or so on and so forth. So sometimes it's easier just to stick with one suite or tool set. In this case, this is just an example, but yeah, there's different setups. You can use GitLab, and GitLab itself has its own issue, like its own issue assigning tool as well. So if you're going to use GitLab, you probably wouldn't use Jira, you know. Or you still can use Jira with GitLab. So it really depends. Like, I think at that point you'd probably plan that out in the planning stage, and because with the SDLC you have the requirements and you have the planning stage, and you figure out what in the planning stage, right? So in the requirement stage, you figure out what features you need, what requirements you have to satisfy, the functional requirements, the non-functional requirements, the quality requirements, the system requirements, interfaces, and all that, right? Now, when you're planning that, that's when you decide, what technologies do we use, what tools do we use, and that's when you have brainstorming sessions or meetings to discuss. We might use this stack or this set of tools because it benefits us with these features, or it benefits us with these functionalities, and I have more experience in this area, or I have more experience in using Bitbucket, and so on and so forth, right? So at that point, that's when you choose when to use different technologies. So for example, if you're just making a normal landing page and it's just a simple landing page, then you probably wouldn't choose React. You'd probably choose like a WordPress, like a CMS, like WordPress is a CMS, so content management system, but it's a really easy to use content management system. So you don't have to worry about coding everything from scratch. But if it's like a custom system where the customer wants you to make a custom app that does custom things, then using something like React, and then that's when you choose the technology stack within the planning stage, right? And then by the time you start actually doing the development, then you would have already chosen what tools that you are going to use, right? Yeah. So okay, so we merge that release into the master, and let's see. Okay, so all branches, release. Yeah, so it looks the same, right? But yeah, here's the release 0.1. And the reason why it doesn't look any different, because release 0.1 is the same as master, right? So they both have the same version of the code. So if you go, for example, master. Oh, actually, sorry. The master itself, right, doesn't have the up-to-date code. So what you'll probably need to do, because it's actually release has the version of the latest of development, but the master doesn't have the latest of development. So what you'll need to do is you probably have to do so I got distracted a bit, but yeah, there's still a pull request. So we haven't actually done the pull request of release 0.1 yet, so it's still not up to date. Sorry. So the master is still not up to date to release 0.1. So what we have to do is we approve it, and then we merge it. But let's just say when we have that third task where it's like, okay, what's the third task that we had for this? So the third task, or the other feature, was change font of counters. So what we could do is, because that's the second sprint, the first sprint, let's say that the first sprint was for the release 0.1, and then the second sprint can be for release 0.2, and that release 0.2 can have this new feature in it, the change font of counters, right? And then now, you merge it, and then merge. And then now we should see it up to date. And yeah, so go back into master. Yeah, master is now, up to date with the release. Yeah. Okay, so I think that's mostly it. And then, yeah, what you could do is deploy it on another machine. So what I could do, right, is go to DigitalOcean, set up another machine, and then deploy it on another machine. But I'm not going to do that because, it's pretty much the same. You just create another, create another instance and then set up Node.js, set up your repository again, pull the code, and then you just initialize the project, and then you start the project, and then as long as if it's checked out on the latest commit, then you should have the latest version, and that's basically how you deploy it. So essentially, yeah, that's basically how you go from the requirements to all the way to deploying on the machine at a basic level. But depending on how your project is set up, there's more complications or more more technicalities once you add extra things to this. Yeah.
Okay. Yeah.
So, and then after that, yeah, there's a maintenance as well. So you'd probably have plugins like health checks, plugins to
schedulers.
Yeah, schedulers, health checks, things to check the health of the server, health of the code, and then it gives you feedback. And then if there's something that crashes or something like that, it gives you a notification. And then also you have like you might have a ticketing system where your customers report bugs on the software, and then they issue a ticket, and then you have to ask them, can you reproduce the issue and then take a screenshot and all that, and then you're going to have to reproduce the issue on your end and see, yeah, this is a bug, and then you create it as like for example, going back to that diagram, that's the other branch that I haven't really talked about. So we talked about feature branches, we talked about development branch, and then release branch and master. Now there's a hotfixes branch, right? So what is a hotfixes branch? So that's when, say, you made a release, right? And then your customer reports a bug, and then they send in like a bug ticket, and they say, this isn't working properly on a mobile device, or like the counter isn't properly sized on my Samsung phone, right? So when you reproduce that, then you say, yeah, this is a issue. So what you're going to have to do is you're going to have to create a another hotfix, right? Just like you're going to have to pull the code from master, and then you're going to have to make the changes on the spot, right? And then test the changes, and then if it works, then you merge it back into the master, right? And then you have to log that bug fix, Yeah. So the reason why you do that, so you up-to-date the change of the master. So you update the master version with the latest fix, right? And then whilst when you've done that, you also merge that change into your development branch, because other developers might currently be making additional changes to the branch, and then you add the bug fix along with their changes, so that current developers don't have to, or the developers that are creating features for the platform, they don't have to worry about fixing the bug. Like someone else fixes the bug, and then they merge the bug fixes with the changes, and then the other people that are working on the additional features, when they merge their coding, because the bug fix is merged with their changes, it's automatically fixed. And then so that's essentially the workflow. And there's a lot of documentation and a lot of theoretical stuff that you can find online to get a better grasp of it. So what are your thoughts, Ro?
I think you've explained every bit of every bit of the SDLC, and I learned a lot from the feasibility study to the deployment. It's very helpful.
So I think next time, because there's probably not going to be enough time, but next time I'll probably get you to do a trial run, and I'll probably create a practice project, and then I'll be the person who reviews the pull request. So you can create the pull request, and then I can just say, can you fix this up, or can you fix that up, and then that way we can sort of practice merging, practice working on feature branches.
Or you can make like a module, like step by step from the requirements gathering to deployment and to the maintenance, like that.
So what I'm planning to do is
we're gonna make make a scenario where someone's a client, someone's the developer, someone's the project manager, so we'll know what are the roles of every person in the development.
So I'll probably run a couple more tutorial sessions, but what I'll do is I'll probably record individual videos for them. So I'll make a requirements collection and analysis video, a feasibility study, design, and then coding, and then testing, and then installation, deployment, and maintains. Because really, this video that we're recording now is sort of like a high level of it from start to finish. But if you break it down in terms of the requirements, then you'd probably spend more time in the requirements collection, because you have to sort of document everything. You have to go back and forth with the clients. You have to approve things with the clients, and so on and so forth. And then with a feasibility study, you would have to do research, look up studies, look up, papers, look up. So for example, if you're creating something new, and then you're trying to figure out, has this been done before? You're going to have to look at, papers that have been published on this. You have to look at, who's actually done this before, and see what methods that they use. So you might end up, using that as inspiration, or figuring out what technologies did they use, and so on and so forth. Because there's no point of reinventing the wheel if something already exists out there, right? And then you have design, and then coding, and then design as well is you've got separate departments or separate sections for that. You've got the front end design, you've got the back end design, you've got the database, structure and design, and the ERDs, and and also the APIs. How do you test the APIs? What frameworks are you going to use to test? And also you're going to have to create a test document. How are you planning to test the code? Are you going to do automation testing? Are you going to do integration testing? How are you going to how are you going to test the user acceptance testing? So how are you going to verify metrics in terms of the definition of done? So when you're scoping things out, you're going to figure out, what is the definition of completing this requirement, right? So what does it need to pass? So for example, in the running app, right, the metric would be the metric of this to test this app would be the buttons are functioning. You could count up to say 20 but in this case, it can count up to more than 20. And then the other metric would be, it has to be a color blue, right? So those are testable metrics because you can test.
Or like, once it meets a certain number, it changes the color, you know?
Yeah, so you're gonna have, say, for example, if you have like a state machine, and it has this the code, or the way that the program works has to follow a certain logic, then you have to have tests for that. Like if I press this button, it doesn't do this, or if I press that button, it doesn't do that. And then you have pass or fail scenarios, right?
Yeah.
So you have to document that fairly well, so that you can sort of, and you also test edge cases, because sometimes the code can actually work. And for example, if you have like multi-threaded applications or something like that, and then sometimes the code can actually work in ideal conditions, but then when you test it on, when you test it on edge cases, then it ends up not working, because for that moment it just crashes the whole thing, or it goes beyond the limit. So you didn't actually have you didn't limit the inputs that can go in within the function. So for example, if you're testing a function, you didn't limit the the edge cases, right? Because sometimes you have to put limits on the edge cases. And then after that, then you do like the installation. You'd have to create documentation for installation. How do you deploy it? How does a user download the code and install on their device? So you're going to have to document that, and then you're going to have to document how to deploy it and the maintenance and all that, so that you could pass it on to other developers. Yeah. And there's probably more to this as well. There's probably different techniques in addition, right? But this is sort of like mostly the way things are developed nowadays. Mostly comes down to the SDLC and and there's like different methodologies. Like there's Scrum, there's the spiral method, there's there's different types of methodologies in how to develop things. But that's when you choose your methodology of development when you're planning, and really what dictates that is when you're collecting requirements, you're trying to figure out, what's the scope of this project? How big is this project? How complex is this project? If it's simple, then we probably don't even need, agile, right? But if it's really, really complicated and there's a lot of, requirements, and it keeps updating, and it's a dynamic project, and so on and so forth, then you're going to need to use agile. If it's like some sort of like really risky project where it has to be like the requirements have to be set at the very beginning, and you can't have the scope changing throughout the project, then you'd probably use waterfall, because but the thing is, when you're planning out the requirements, you're going to probably spend months just to figure out the exact requirements that the system needs. Sometimes some projects even spend like a whole year just trying to figure out what the requirements are for the project, and then the next year you start developing that project. So it really so that's when it really depends on the project that you're doing.